Okay, hello children. So today's class we are going to start with the 12th standard portion. So 12th standard physics unit 1 electrostatics. In that I am going to start with the important 5-mark questions. So today we are going to discuss about electric field due to a dipole. So in that we have two cases. One is the axial line, another one equatorial line. So today first we will learn about axial line. So for this we have to consider an electric dipole. So this is a electric dipole. Two equal and opposite charges. So here we have minus q which is located at the point A, and we have plus q which is located at the point B, and the midpoint of A and B we have marked it as O, and from the midpoint the charge minus charge is located at a distance of A. Same way from the midpoint the plus charge has been located at a distance of A. So now this is said to be an electric dipole. Two equal and opposite charges, and they are separated by a distance. The total distance is A plus A becomes 2A. Okay, so this is the electric dipole. Now we are considering another point C. Okay, this point is being located at a distance of r from the midpoint O of the dipole on the axial line. Axial line in the sense we can consider this as a towards a x axis. In maths you could have learnt about x axis and y axis. So we represent this one as a axial line. Now starting with the electric field. So the electric field at a point C. Okay, the electric field at a point C due to plus Q is. So due to the charge plus Q, what is the electric field at the point C? Okay, so here that is on the either sides of the point C, we have marked the electric field, that is E vector. One is a negative electric field, another one E vector, that is a positive electric field. And if you see the distance of these lines, one is the shorter, the negative one, and another one is a little bit longer one. Okay, that is the electric field at a point C due to the charge plus Q. First we are considering the positive charge. Due to the charge plus Q, what is the electric field at the point C? So that is given by E vector plus is equal to 1 by 4 pi epsilon naught into Q divided by R minus A the whole square, which is along BC. See, I think you could have learnt this one in your 10th standard itself, even in 11th standard. This is according to the universal law of gravitation. So the force acting on a body is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Using that rule only we have written this. So the value of k, we will remove the directly proportional sign and we will introduce the constant k over there. So the value of constant k is 1 by 4 pi epsilon naught, and then q. Okay, since we have considered as a positive charge, so plus q divided by, now the total distance, that is from the midpoint towards C, the total distance is r, but the positive charge is located at a distance of A. So that we have taken as a r minus A. Can you understand? From O to C the total distance is r. From O to positive charge the distance is A. So r minus A the whole square. Okay. Now next one, same way, the electric field at a point C due to minus Q. Due to minus Q is, now you have to consider as E minus vector is equal to, here you will have a minus sign in before, that is minus of 1 by 4 pi epsilon naught into Q divided by, here minus Q is located at a distance of A from O. So already we have a distance of R. We have to consider this A also. So here you will have to write as a R plus A the whole square. Okay, and here we will consider a electric dipole moment vector. Okay, this electric dipole moment vector is P vector, which is been moving from minus q to plus q. So from minus q to plus q, there is the electric field, electric dipole moment vector, that is the P vector. Okay, so this one we have to include in both the equations. Now let us consider this as equation 1 and this one as a equation 2. So now let us consider, we have to include this electric dipole moment vector. So we will have the equations as electric field positive is equal to 1 by 4 pi epsilon naught into q divided by r minus a the whole square into p cap. What is it? P cap. Cap represents the unit. Cap represents the word unit. That is electric dipole moment unit vector. Same way for negative electric field we will have E vector negative is equal to 1 by 4 pi epsilon naught into q divided by r plus a the whole square into p cap, and in front we will have a minus sign. Is that clear, children? Now we have to find the total electric field. So the total electric field at the point C. Okay, so E total. Okay, E total vector is equal to E plus vector plus E minus vector. So now 1 by, substitute the values, 1 by 4 pi epsilon naught q by r minus a the whole square into p cap, again plus, but here it is a minus, isn't it? Minus of, you can put the bracket, 1 by 4 pi epsilon naught into q by r plus a the whole square into p cap. Okay, now we can take the common terms outside. So q divided by 4 pi epsilon naught and p cap can be written as common. Now open the bracket. So 1 by r minus a the whole square minus 1 by r plus a the whole square. Now you have to take the LCM for this. So E total is equal to q by 4 pi epsilon naught p cap into, here take the LCM. So how will you take the LCM? So this is of the form like r minus a the whole square into r plus a the whole square, and here for the numerator you will have r plus a the whole square minus r minus a the whole square. Is that clear, children? Now again E total vector is equal to q by 4 pi epsilon naught p cap into, so this is of the form a square r minus a square into r plus a square can be written as r square minus a square the whole square. Okay, and this one is of the form a plus b the whole square. So you can expand it in that form. So a square plus 2ab plus b square. Same way r square plus 2ra plus a square minus, again this one is of the form a minus b the whole square. So again r square minus 2ra plus a square. Okay, now the next step, you can bring the minus sign inside the bracket. R square plus 2ra plus a square minus r square, minus into minus becomes plus, minus of minus becomes plus 2ra, and here it is minus a square divided by r square minus a square the whole square. This denominator is in the form of a plus b into a minus b, which is equal to a square minus b square. The same format only, the same formula only we have used here. So r square minus a square the whole square. Okay, now you can cancel r square plus r square minus r square. Same way minus a square plus a square get cancelled. So now you will have q by 4 pi epsilon naught p cap into 2RA plus 2RA becomes 4RA divided by r square minus a square the whole square. Is it clear, children? So now here, if the point C is very far away from the dipole, okay, suppose the point C is very far away from the dipole, then comparing r square value and a square, this a square is very small and so it can be neglected. Okay, a square is neglected. So now we will have E total vector is equal to Q by 4 pi epsilon naught P cap into 4R A divided by, we will have only R square the whole square. So in turn we will have Q by 4 pi epsilon naught P cap into 4RA divided by R power 4. Is that clear, children? So electric field vector total vector is equal to 1 by 4 pi epsilon naught into 4RA divided by R power 4 into P cap. So here 1 R from the numerator and 1 R from the denominator get cancelled. So balance we will have 1 by 4 pi epsilon naught into 4A divided by R cube into P cap. Okay, but we have learned that 2A Q into P cap can be written as P vector. Is it clear, children? So now E total vector is equal to, sorry, here we have a Q. So this one can be splitted and written as Q by 4 pi epsilon naught. This 4A we can write it as 2 into 2A. Okay, 2 into 2A divided by R cube into P cap. So now here this 2A, this Q and this P cap, all these three terms can be combined and written as P vector. So we will have E total vector is equal to 2 P vector divided by 4 pi epsilon naught into R cube. Okay, this is because R is very greater than A. Suppose if we choose the point, C towards the left side. Do you remember, children? Initially we were choosing it in the right side. The point C is chosen towards the right side of the dipole. But suppose if it is chosen towards the left side of the dipole, then the total electric field is also still in the same direction of the electric dipole moment vector P. So this is the final expression for electric field due to a axial line. So we will have E electric field total vector is equal to 2P vector divided by 4 pi epsilon naught into R cube. This is for the condition R is very greater than A. Thank you.